Welcome back. We're looking at diversity and change, and we're going to be focusing now on quite a contentious issue. When people consider the theory of evolution, they often say, yes, but evolution happened long ago. It doesn't happen today. Can we find evidence of evolution in our present time? And the answer to that is an overwhelming yes. Now we know that species take long times to actually become a new species. We know that speciation is a process that occurs over thousands and thousands of years, but there is evidence for organisms evolving in our lifetime. So shall we have a look at some examples of how evidence of how evolution is happening today? You should now be very, very familiar with our little green and red beetles. Remember that this was a hypothetical example. This was just an example that I made up because I like the look of these little beetles to illustrate to you what we mean by evolution. We know in our little hypothetical example here that the green beetles and the red beetles have their color because they've been programmed genetically. They've got genes for either a red shell or a green shell. And we know that in our original population, there's no advantage to being red or green. It's just a random thing. We also know in our little story that environmental circumstances changed. Do you remember we said that a bird population came to live in this particular area? The birds could only see red. And so therefore, they loved eating these little beetles, and they would be able to pick up the red beetles and eat them far more easily than they'd be able to see the green beetles. So suddenly it became disadvantageous to be red, but advantageous to be green, because if you were green, you could hide, you were camouflaged. That means you lived longer, that means you generally produced more offspring, and those offspring, of course, carried the gene for green shells. And so if we went looking at time 1, if we went to time 2, after a significant amount of time had passed, and we looked at the same population, we would see that the gene frequency of red to green shells has changed. And now we see that our population is predominantly green. And that is what we call evolution. We know that natural selection favors the stronger individuals, and we know stronger doesn't necessarily mean muscles and strength. Stronger or fitter individuals means those more likely to cope with the environmental circumstances. So, by now you should have a very good understanding of how evolution takes place and how natural selection is the process that drives evolution. So, getting back to our original question, has evolution ever been observed happening? Can we see it happening today? A common misconception is it's never been observed, and that is actually incorrect. And we're going to look at 2 examples today where you can prove to somebody that it is happening today. One example of evolution, remember, all evolution is a change in the gene pool of a population over time. One example is the way insects develop resistance to insecticides over a period of time. You may have heard of farmers or people trying to get rid of a particular insect pest in an area, spraying with an insecticide, and then after many generations, we find that this insect is resistant to the insecticide. No matter how much food the insect eats that has this insecticide on it, it will not kill the insect. So clearly these insects have developed a form of resistance. So let's see how this happens. Let's once again say that we have a population of insects. This is our hypothetical example again. Let's also say that these insects are considered pests because they bite humans and they transmit diseases. We could imagine that this population might represent mosquitoes that carry the malaria parasite. And now we're going to move from the hypothetical into the real world. This does exist. There are mosquitoes. They do carry parasites that cause malaria in humans. And we also know that many of these insects, the malaria mosquitoes, are immune or resistant to certain insecticides. So how did that happen? Now I want you to remember those pictures of the red and the green beetles, and I want you now to have a look at our new picture, little blue and little purple insects. In the same way, in our original population, we know that most of our little insects carry gene A, and they are very, very susceptible to the insecticide. Now, scientists develop this insecticide. It kills these insects. They are susceptible. That means that the insecticide will kill them. But in our little population, we could say that having gene A represents the gene for normal insects, and they are not resistant to the insecticide. They would live long enough maybe to produce offspring, but the offspring are killed by the insecticide. That is our population at the moment. When you come back after the break, we're going to see how this population would change over a period of time. I want you to focus on that little insect there that has gene B, and during the break, see if you can figure out how the story is going to end.